Dear students, today we will solve one example from the topic integration. Our concept is integration by method of partial fraction. In our last lecture we have discussed the type number 1, that is whenever in the proper fraction, whenever the denominator is expressed as distinct linear factors. If the denominator is expressed as distinct linear factor, that is our type number 1. And from the exercise number 5.6 of your textbook, we will solve one example. So let us see one example. Evaluate. See here, integration x square plus x minus 1 upon x square plus x minus 6 dx. Now if you observe the numerator and denominator, then this is a fractional part, means it is called as rational function, and the degree of the numerator and the degree of the denominator, if you observe this carefully, then degree of the numerator is equal to 2 because the higher index is 2, and similarly the degree of the denominator is also 2. So here in this case, this is not a proper rational function. Proper rational function means what? When the degree of the numerator is less than degree of the denominator, then it is called as proper rational function. But here the degree of the numerator is equal to the degree of the denominator, hence it is called as improper rational function. So to solve this, first of all, see how will you write this. First of all, we will consider I is equal to integration x square plus x minus 1 upon x square plus x minus 6 dx. Now remember always, whenever the degree of the numerator is equal to degree of the denominator, then always remember that we have to express the numerator in terms of denominator. That means, see here, in the next step you will observe here carefully that the integration, the numerator is denoted as x square plus x minus 6. See, it is expressed in terms of denominator. So denominator is x square plus x minus 6, and originally it is x square plus x minus 1. Here it is minus 6 we have taken. So if we add plus 5 here, then you will get the adjustment. So x square plus x minus 6 plus 5, this is called as the numerator which is expressed in terms of denominator. So whenever you have the function which is a rational function where the degree of the numerator is equal to the degree of the denominator, then try to express the numerator in terms of denominator like this. So this is very, very important. Now next step is what? We have to take a separate denominator. Take a separate denominator, then you will get first integration, you will get it as 1 dx. Why it is 1? Because x square plus x minus 6 upon x square plus x minus 6, that means 1. And next one is plus 5 upon x square plus x minus 6 dx. So this is just by separating the denominator. Now next step, just you take 5 outside of the integration here. See this carefully. So we get integration 1 dx plus 5 times integration 1 upon x square plus x minus 6 dx. Now that integration is very, very important. Say this is equation number 1. Now see the next part here. Now integration of 1 is very easy. Now how will you get the integration of 1 upon x square plus x minus 6? See here, in the denominator there is a quadratic equation. So now we will factorize that quadratic equation. So factors are 1 upon x plus 3 into x minus 2. This is the factorization, and both are linear factors, x plus 3 into x minus 2. Just by rough work you can obtain this. So x plus 3 into x minus 2 are two distinct linear factors. Now we will apply the partial fraction method to evaluate this integration as per the type number 1. So let us see. Now you can write 1 upon x plus 3 into x minus 2. We can write it as a upon x plus 3 plus b upon x minus 2. Okay, this is our partial fraction method. So rational form is converted into partial form, that is a upon x plus 3 plus b upon x minus 2. Now we have to determine the value of a and b. So next step will be, just by cross multiplying you will get, see, left hand side you will get only 1, since we will cancel out x plus 3 into x minus 2 from both sides, and here what will you get, a into x minus 2 plus b into x plus 3. You will get like this, 1 is equal to a into x minus 2 plus b into x plus 3. Now we have to determine the constants a and b. Now to get the value of a, we have to remove b. Now here there is a factor x plus 3. So if you put x is equal to minus 3 in it, if you put x is equal to minus 3, then it will get 0. So put there. So we get 1 is equal to a into bracket minus 3 minus 2 plus b into minus 3 plus 3. So b will get cancelled, and see here carefully, we get 1 is equal to minus 5 times a. See the calculation, and hence we get a is equal to minus 1 upon 5. So this is the method to obtain the value of a. Similarly, now we will calculate the value of b, and for that now we will put x is equal to 2. Now if you put x is equal to 2, then a will get cancelled. So just see the step. So we get 1 is equal to a into bracket 2 minus 2 plus b into 2 plus 3. See carefully, and hence a will get cancelled, and hence we get 1 is equal to 5 times b. So that implies b is equal to 1 upon 5. So the partial fraction method is completed now here. By obtaining a and b, we get the conversion of rational form to partial form. Okay, so hence 1 upon x square plus x minus 6 is equal to, or it is converted to, minus 1 upon 5 upon x plus 3 plus 1 upon 5 upon x minus 2. Now hence equation number 1 becomes, okay, we get like this. So I is equal to integration 1 dx plus 5 into integration of, now we will evaluate the integration, that is minus 1 upon 5 upon x plus 3 plus 1 upon 5 upon x minus 2 dx. So again we will rewrite this. So what we get, see here, integration 1 dx. Now take a separate integration of this. So 5 and 5 will get cancelled. So here you will get minus of integration 1 upon x plus 3. Here also 5 will get cancelled because it is 1 upon 5. 1 upon 5 into 5. So that is 1. So integration of 1 upon x minus 2 dx. Now it is very easy to evaluate the integration. So next step is, now integration of 1 is x minus integration of 1 upon x plus 3 is log of modulus of x plus 3 plus integration of 1 upon x minus 2 is log of modulus of x minus 2 plus constant. So this is our final answer. So in this example, the numerator, degree of the numerator and degree of the denominator both are same, and in that case we express the numerator in terms of denominator, and to the second integration we apply the method, that is the partial fraction method, and hence we evaluate the integration. So this is the procedure for type number 1. Okay. Thank you.